Hi, welcome back. In this video we're going to look at finding the distance between 2 points and also the midpoint between 2 points. Let's start with a picture here. We have 2 points, so we're going to call the first point x1, y1, and the second point we're going to call x2, y2. And we've plotted this on the Cartesian coordinate plane. The horizontal here is the x direction and the vertical is the y direction. Okay, and I've just put these right here in the first quadrant here. So here's a point, there's a point. And we're interested in the distance between the 2 points. All right, the question is, well, how do we calculate that? Now, if the 2 points were on the same horizontal or vertical line, it would be easy. We would just count the number of units between them. Here, though, they may not have. It could be the case that they don't have the same x or y coordinates. All right, so what we'll do is we're going to kind of investigate this picture a little bit. The first thing I want to do is to draw the locations of both x1, so there's x1, y1, so there's y1, and then I'm going to extend that over here. So this line is of all the points that have a y coordinate of y1, sorry. And then right here we would have x2, and right up here we have y2. Okay. Now, we might see the shape right here. You might notice that this is a triangle. Better than that, it is a right triangle. And the distance that we're trying to find happens to be the hypotenuse of this right triangle. And so if we could figure out the sides, we could use the Pythagorean theorem to then find the distance d. Okay, so let's look at this vertical side here. How far is that? Well, notice that this point, which is the vertex of this triangle, where the right angle is, all these points would be on this vertical line, so therefore they'd have the same y coordinate, same x coordinate. And that means that the distance between these points is simply the difference in the y components. So I'm going to go ahead and put an absolute value here because these are arbitrary points. We don't know whether this first point is higher or lower than the other point, trying to be as general as possible here. So anyway, we'll take y2 minus y1. All right, so this is the distance here. We want to find the distance here, and in the same way, these 2 points have the same y coordinate. And so the distance here would be the difference in the x's. So x2 minus x1, again, an absolute value. All right, now we can use the Pythagorean theorem, and remember that says that the square on the sides, the sum of those, would add up to the square on the hypotenuse. So we'll take x2 minus x1 squared. We don't need the absolute value because when we square something it becomes positive, or at least non-negative, plus y2 minus y1 squared. That equals d squared. So we applied the Pythagorean theorem. Now to get d, we just take the square root of both sides. So I'm going to start with d on the left-hand side. So we'll have the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, and this is the distance formula. So if we want to find the distance between 2 points, we just plug it in to this formula, compute this square root, and we'll have the distance. Right? let's go ahead and take a look at that. So here's a couple of examples, -2, 3, and 10, 2. Let's find the distance between them. We just need to set up the distance formula. So d is going to be the square root of, it doesn't matter which one you choose as the first point and the second point, so long as you're consistent as you're filling this out. So x2 minus x1, let's call this one x2, so 10, minus a -2, so that's actually plus 2 squared, plus y2, which is 2 minus 3 squared. So 10 minus -2, 2 minus 3. All right. 10 plus 2 is 12. So we'll have 12 squared, -1 squared. 12 squared is 144. 1 squared is 1. So we get the square root of 145, which is around 12. All right, let's do another example. So here we have 3 comma -3 and -9 comma 2. So I'll have the difference in the x squared, difference in the y squared. If you'd like to, now would be a good time to pause the video and work this out. 3 comma -3, -9 comma 2. All right, let's see. We got the difference of the y's, so 2 minus -3 plus 3, -9 minus 3. All right, so we've got 2 plus 3 is 5, 5 squared is 25. And then we have -9 minus 3 is -12. Squared is 144. 25 plus 144 is 169. And the square root of 169 happens to be 13. Okay, one more topic we can talk about is the midpoint. And let's go back to the picture. So we're interested in the point that is halfway between two given points. Now if we can imagine this being either a horizontal or vertical line, the midpoint's simply going to be the average of the two components. So imagine this line segment right here. Halfway between those, right here, in line with this distance equal to this distance. So we could take x2 plus x1 and divide by 2, right, to get this. The midpoint here would be the average of the y component, so y2 plus y1 divided by 2. Right, and you may notice that those both line up to the midpoint of this line segment between the two given points. Right, so to find the midpoint, we just want the average of the coordinate points. So x2 plus x1 divided by 2, y2 plus y1 divided by 2. Right, now notice the midpoint is a point, right? So it's got an x component and a y component. You could plot it. It would be halfway between the two given points. All right, so we've got a couple of pairs of points. Let's go ahead and take a look at what the midpoint is. So this first one, right, we'd have a midpoint of -2 plus 10 over 2, comma, 2 plus 3 over 2. So our midpoint is 8 halves, comma, 5 halves, or 4 and 5 halves. All right, let's do the same thing with the second pair of points. The midpoint's going to be -9 plus 3 over 2, comma, 2 minus 3 over 2. So we will have negative 6 over 2, comma, negative 1 over 2, negative 3, comma, negative 1/2. All right. So we've looked at the distance formula to calculate the distance between 2 points, and the midpoint formula to find the midpoint between 2 points.